Hello everyone, we are Team Rebase and today we are presenting AI keyboard, making every keystroke intelligent. I'm Yogita and my teammates are Neha, Tijesh and Tejas. So before starting, let me tell you what happened yesterday. As usual, I woke up late and then I remembered I had to send an email to my professor. So I hurried. I started typing, respected sir, I hope this mail finds you well. And 2 minutes later, I switched to WhatsApp. I was texting my friend, bro, did you finish yesterday's assignment? So, did you guys notice something? Yes, same hands, same keyboard, but completely different language. But my keyboard didn't understand this. It treated both languages the same. So, we type all day, but our keyboard still doesn't understand the context. So, we are introducing a solution AI keyboard. Moving on to the second slide, our proposed solution. AI keyboard is an intelligent layer between keyboard and applications. It has four capabilities: context-aware suggestions, voice to formatted text, automatic personalization, and universal compatibility. When we talk about context-aware suggestions, it detects which app you're in. For emails, it gives professional suggestions, whereas for Slack, it gives casual text with emojis. When we talk about voice to formatted text, just speak or email John regarding the deadline on Friday. It gives completely formatted email, not just raw texts. When we talk about automatic personalization, it learns about your context. It learns that you prefer hi over dear. And when we talk about universal compatibility, it is nothing but it can be run on all types of desktop or browser. So handing over the slide to Neha Vaskar.
Thank you, Yogita. I am Neha. I'm going to explain about the system architecture and the speed optimization of our solution. So, coming to the system architecture, it basically follows one simple idea, which is one brain and many clients. So, coming to the brain part, it is the core AI engine, which runs locally on the user's machine, and it contains all the intelligence components such as context detection, personalization, and suggestions. So two clients, which are browser extension and desktop application, connect with the core AI engine. Browser extension is used for capturing the typing in websites like Gmail, Slack, LinkedIn, etc. And desktop application is used to capture the typing in native apps like VS Code, Word, etc. So both the clients communicate with the core AI engine through WebSockets for real-time responses. Since the intelligence is centralized, so any improvements we make is automatically benefited by the clients. So next, let's go to the system speed optimization. Since speed is very critical, and even if the AI responses take 2 to 3 seconds, it won't be useful. So we have come up with a three-layer architecture. So coming to the layer one, it is the cache. It is used to store the common phrases locally, and those can be retrieved instantly. It takes about 0 to 10 milliseconds. Next, coming to the second layer, it is the local AI. Um, it is basically a small model which runs on the local machine through OLAMA, and it takes about 10 to 100 milliseconds, and it doesn't cause any network delay. Coming to the layer 3, it is the cloud AI layer. Um, since if the requests are complex, we rely on GPT-4, and the streaming is done for increasing the responsiveness. So it takes about 100 to 500 milliseconds, and all the requests, about 70% of the requests are handled directly by the layer 1 and 2, which is local. So the responses are almost instant. Next, Tijesh will continue with the further part. Thank you.
Hi, my name is Tejesh and I'm going to continue with the presentation. Context detection. Let's see how an AI keyboard knows which app you are in. In browsers, we analyze the URLs. Suppose if the URL is mail.google.com, then we'll know that it is Gmail. If it is slack.com, then the AI will know it is Slack. In desktop apps, we read the title and the process names and determine the app. Based on this, the suggestions adapt automatically. For example, in case of Gmail, the tone is more formal. When it comes to Slack, the tone is very casual. In case of VS Code, it should be more of technical, and it should also provide a code snippet completions. The context switching happens in under 50 milliseconds. Next is voice integration. We also support voice integration using the Whisper model, which is an OpenAI speech to text model running locally. We go beyond a simple transcription. We do intent enhancements. For example, if you say, email John about extension of the deadline to Friday, normal transcription gives exactly those words. Our output is as follows. Hi John, I wanted to check if we could extend the deadline to Friday. Let me know. Best regards. So here we understood the intent and formatted it as an email. So thank you. Next, my friend Tejas will continue with the presentation.
Hi, I'm Tejas. Let me explain how AI keyboard learns your personal writing style. We have a three-layer learning system. Layer 1, explicit preferences. These are during the initial setup of the user. You can use optionally and tell your role like you're a developer, writer, manager, or even a student and your preferred tone. This helps us start with good suggestions, but this is completely optional. Observe patterns. This is where the real learning happens. As you use AI keyboard, we observe your patterns. We notice you start with hi or dear, writing emails. We notice the words like it sounds good, that's great, while using Slack or WhatsApp, and feedback loop. Every time you accept a suggestion, the pattern gets reinforced. And whenever the suggestions are dismissed, we learn to avoid that type of suggestions in the further ones. As an important distinction, we store the patterns but not the content. We remember that the user prefers the words like hi or dear and do not store the actual content or the messages or the text that the user inputs. And the emails are not never saved. Coming to the security architecture, which is our highest priority, you might wonder, this is reading my emails and messages, is my data safe? But actually, the core principle of this AI keyboard is to use the content, but not to store the content. Here's exactly what happens. Our AI reads your text temporarily in the memory. We extract general patterns like users prefer for the formal tone. We generate the suggestions to the user. Your actual text content is immediately discarded and never saved or never sent anywhere to the external servers. What actually gets stored is the user's preferences or the patterns and the style of the user, like informal greetings in Slack and the formal emails. What actually doesn't get stored is the actual content that which will never be stored. We also have automatic protection for the banking websites, password managers, and the login pages, which are auto-blocked. The AI keyboard completely disables itself on these sensitive sites and the applications. And you have manual controls using some shortcut keys also for to instantly pause the background AI. Coming to the MCP integration as a plugin for Fry, the final round AI ecosystem. This is important that AI keyboard is built as a plugin for the Fry ecosystem. Fry can connect this AI keyboard as a plugin using this MCP, Model Context Protocol. Think of MCP like USB, a standard way for AI tools to connect and communicate with each other. We have designed AI keyboard as an MCP server that exposes for tools any ecosystem can use. Detect context tells the fry which app the user is currently in. Complete intent provides intelligent text suggestions, enhance the text, improves selected text on demand, transcribe voice, convert speech to properly formatted text. Because we have built it as an MCP plugin, AI keyboard integrates seamlessly with the Fry platform. Any Fry user can access intelligent keyboard assistance directly through the ecosystem, or else the Fry um, uh, administration can use this MCP plugin for their external usage. And the beauty of this MCP is its extensibility. The same plugin also works with other applications also, like the cloud desktop or any other platforms can also make use of this. Uh, Let me show you a small demo of the AI keyboard, the initial version or a small component of the AI keyboard that we have built. Let us say we are writing an email to so and so email. In this inbox, let us say um, they just oh, and the suggestions are being shown. See, these are the AI keyboard suggestions that are being suggested by the AI keyboard. Uh, this is how the AI keyboard suggests messages or any text to the user in the browser level. And in the desktop level, the user can use the native desktop software of AI keyboard that will be built. We have built this web extension named Rebase. And it has settings like this, features, shortcuts to accept the suggestion, dismiss, trigger, rewrites, pause or resume the AI keyboard, and privacy controls to clear the data. Uh, the general controls are in the suggestion delay system, AI mode. The AI that we are using is in two modes, right? One is the cloud and the offline one. User can select whichever the way he wants. There is the web extension that we have built for now, basically, and the voice integration through Whisper. OpenAI's open source model will also be used, uh, and the desktop version will also be built in similar way. And thank you.